Hey everyone, today we'll be doing another LeetCode medium question, islands and treasures. It's pretty weird because it's called walls and gates here, but yeah, I don't really know which one to follow, but whatever. So I did do a couple of LeetCode questions earlier with my friend. One of them was an interview style, and then I did I think two just normally, but I didn't record it, and I guess I don't want to miss a day or whatever. So let's try and do this problem. Hopefully it doesn't take too long because I do have a little bit of a headache. It's been a long day. Whatever. Alright, let's go. So let's read the problem. You are given a m times n 2D grid initialized with three possible values. -1, a water cell that cannot be traversed. 0, which is a treasure chest, and a land cell that can be traversed. Okay, and we use this integer. So we fill each land cell with the distance to its nearest treasure chest. If a land cell cannot reach a treasure chest, then the value should remain infinite. Okay. Assume the grid can only be traversed up, down, left, right. Okay. So it's just finding... So I'm basically going from infinite to 0. Yes, finding the closest path from each grid, okay. I'm trying to think if there's an easier way of doing this. So my first instinct is to just, for each thing, for each big number, I try to go to the nearest 0, but here's the thing, I can actually reuse these values. So I'm guessing I'm modifying in place. So I can actually reuse these values. So for example, starting from 0, I can go there, and so on and so forth. Actually, wouldn't it be better if rather than going from every single infinite value, we go from a 0 and then modify any infinite value that we encounter? I think that makes the most sense. That way we don't have to worry about all this yada yada stuff. So DFS, what would be the, I guess, row and column, and let's just use dist for distance. And I think it's always good to define rows and calls at the beginning. I don't know if we'll need to use it. We probably do, but it's just a good, I feel like if I don't, I can just remove it. What is the condition here? If r is less than 0, or c is less than 0, or r is greater than or equal to rows, or c is greater than or equal to calls. There's probably one more condition. Or grid RC is equal to -1, then we can return 0, because that's like the so we go there, return 0. So if grid RC is equal to, man, do I have to, can I just copy paste this or something? Bro, this value, what the hell, bro? Can you at least do like some other value than infinite? If grid is equal to whatever the hell that is, then grid RC just the distance. Well, I guess we would need to increment that first. And now we can DFS r plus 1, c plus, distance, r minus 1, c plus 1, and c minus 1. So the idea here is to start from a 0 and then kind of build up the value. But that's the thing, right? Like, I need to find the minimum. And if I encounter multiple zeros, it might overwrite it. So how are we going to do that? I think you do this. If the answer is greater than 0, we actually find the minimum of distance and grid RC. I think that makes the most sense because say I go here, oh, that's the minimum. But if I go there, we might do that actually, yeah. Then we'll just compare it to its value at the time because this also applies. Maybe that's why the value is like infinite, because the path might be like that or something. This makes the most sense. Okay, this is looking really good. Now, for our in range rows, for C in range calls, if grid R C is equal to, what was it, 0, then we DFS RC 0. This is my answer. I think this makes the most sense. We'll see. Okay, so this is wrong. Why is that? I think there's an issue with the limit. Let's see what's going on here. I think maybe I just return this actually. If R is less than 0, R is greater than or equal to rows, or grid is, oh, why did I make this a string? Okay, something is still wrong here. I'm gonna print it out. So oh, actually maybe I shouldn't have done it there. Oh. So what's going on here? Three, 2, and I'm stuck. Why is that? My question is, why is R and C remaining the same, even though I am incrementing it? The only thing changing is the value, but everything else remains the same. Why is that? So we're starting at 0 to what the hell? Oh, I see. So it's like I'm going up and I'm going down. Up, down, up, down, up, down, down. So I'm visiting the thing again. Okay, I see. Yeah, this is why they have a visited function, huh? Well, we're gonna add this. We'll make it a set for RC and visited. So yeah, or RC is visited, and then in here visited.add RC. So that should handle that case, I think, maybe. It's just going back and forth. So this way it's not traversing it. No way, but then that might not be right, because let's do this. No, okay, what's going on here? So I should put this here, actually. Oh, nice. Is that actually the answer? Damn, oh no. Time limit is seated. What's going on here? What is this fucking example, bro? Okay. Bro, what the hell? Let's see if I actually have the right idea by... Yes. DFS, bro, I have DFS, my guy. Okay. Huh. I don't know if this might be necessary, but I'm just gonna find this now. This is just like a list of direction that I might need to use for row, like letting rows or something. Okay, so len queue is equal to length queue. Simple enough. And for I in range and queue RC top left. Okay, so this is the first treasure chest. Now what do we do? Well, we look in the directions, right? So for drdc in directions. Actually, I'm gonna do row and call here, so it's more. I just don't overwrite it. Row plus dr call plus dc. Okay. So now we're going like boom 1 1 1 1, right? So starting from like here, we're now checking there. If row dude, this is so weird. If row if okay, row if r is less than 0 or c is or c not in range calls or then it means it's just bad. Else, what do we do? Bro, how the hell do I add? Keep track of count. What the fuck? It's kind of tough, man. So I start here. Let's look at an easy example, okay? We add that. Pop, boom. We look left, right, up, down, okay. Boom. That's, nope, we continue. Now we look at the bottom one. It's an infinite, so what do you do? Dude, I might need to do that, bro. Grid RC is min. Grid RC. Dude, what is this solution, my guy? Specific dot add grid RC. Nice, Steve RC. And now, no. Gotta add this to the queue, my guy. Well, what is this answer, my guy? Oh, it is D. God damn it, dude. I changed that midway and I was like, is this the case? Length. Oh, my bad. I'm sorry, bro. I got it wrong. Dude, I didn't even change anything. Okay, I think I'm close. My numbers are just a little bit off, so let's look at why. So distance is +1. So it starts off at distance 0. Because in this approach, the treasure cells self-mark the cells level by level, and the level number will be the distance from that cell to. You don't revisit a cell. Why, bro? Why? Multi-source DFS. What is that? Dude, I'm so close. Fuck this shit. I'm pretty sure it has something to do with the visited because I'm not doing it properly. Graphs are so trippy, man. I need to do so much more of them. Modify the grid in place. Yeah. My DFS approach earlier actually worked. It's just too long. Cite the neighbor loop. I see. Oh my god, is it actually? No, wait. Oh, that's so dumb! What? Okay, so this has a time complexity of n times n. And, space complexity of... I'm gonna say m times n as well because we're going through everything in there. Yep. Now, let us see. Dude, is DFS not a solution? No, bro. Wait, might be this one. Yeah, this is my solution. Does that make sense? Wait, no, that's infinite, bro. Yeah, why are they going from infinite? Dude, that doesn't make sense. So you do go from 0. Yep, that's smart. Add cell. What the frick? I guess I could also do that. Would that make a difference? I was able to get the solution for the most part. I did have to look at the hints, but I didn't look at the answer key until like the very end. I did have to ask GPT for just a final check what the hell is happening. Simple mistake, I just had to move this up because it was just changing as it goes down. Which makes sense. It's basically increasing for every direction every time this loop happens. Dude, this doesn't even care about the min. Oh, what the hell? It's kind of nice actually. Wait, let me just hide that real quick. Visited.add. Yeah, this works. I don't even know why. I don't even know why this works. So my question is, why does this work? Because, you know, treasure chests can be multiple, distances away. So how do you know what the minimum is? That's my question. How it doesn't get takes into account multiple treasure chests. Yeah, like if there's a treasure chest here, there's two treasure chests, right? How does it know to take this one, 1, 2, 3, rather than like this one? Okay, I get that. Oh, multi-layer BFS. Right, I get it. So I basically add this and this, right? So I look through this and see everything around it. Boom. And then I don't check that. It's not DFS. I don't go down that. I go here next and I check the surrounding of that. And then I check the surrounding of the ones at the beginning. These fucking shit. And then this fucking shit. And then process repeats. That makes sense. Okay. Yeah, so yeah, this is way better than my DFS approach. My DFS approach basically starts from a 0 and then it just kind of like goes until it can't go. But that might be inefficient if you have multiple treasure chests because you're just revisiting things over and over again. I don't know, I feel like that makes sense. But maybe not, because I'm thinking if I have DFS, I'm basically gonna have to go through the yeah, if I use DFS starting from 0, I'm gonna have to go over the values multiple times, and that's basically what I did. I feel like it does give me the answer, but it's just too long because it's just repetitive, whereas with BFS it really is layer by layer. So yeah, that makes sense. Okay, very good, very good.